All right, here we go. Section 11.6, reference angles. So our goal for today is to be able to find values of a trigonometric function of an angle that is greater than 90, but we're going to use a reference angle. So jumping on in, the reference angle of theta is an acute angle formed by the terminal side of theta and the x-axis. So what you really need to know is that the reference angle is an angle measure between 0 and 90. Okay, so for example, if I ask you to find the reference angle for 140 degrees, you're going to start at your positive x-axis. You're going to work all the way. Remember, this is 90, 180, 270, and then this would be 0 or 360. So 140 is somewhere between 90 and 180, so we're back here. But I want to find the reference angle, and the key here is it has to be acute, which means it's between 0 and 90 degrees. So we're going to start from the terminal side, so that means we're going to work from the bottom up here. 180 minus 140 would be 40 degrees, so my reference angle would be that 40 degrees. If you have radians, for example, you might want to first convert radians to degrees. So we are going to take negative 3 pi over 4. We're going to multiply by 180 over pi. The pi's are going to cancel out. And we could probably cross-reduce the other way too a little bit if we choose, or you can multiply straight across, doesn't matter. But 3 times negative 180 is negative 540. 4 times 1 is 1. And then if you simplify that, it's negative 135 degrees. So you always start from the positive x-axis. Again, I'll put these on here one more time. You always start from the positive x-axis over here. And if it's positive, you go to the left, you go counterclockwise. If it's negative, we go clockwise. So I'm going backwards 135 degrees. So if I go and I stop here, that's 90, so I need to go a little bit further. So here would be that angle of negative 135 degrees, but I want the reference angle, the angle that's somewhere between 0 and 90. So I'm going to start from the terminal side here, work towards the angle. And then, so we're basically taking 180 minus 135. What's left is a 45 degree angle. So my reference angle then would be 45. Let's try another one. So negative 130. So again, we're going to start here from the positive x-axis. We're going to work backwards 130 degrees. So I go past 90, but don't go past 180. So we're somewhere out here, kind of close, probably not perfect. So we're going to take 180 minus 130, and that leaves me with a 50 degree reference angle. For the last example here, we have 5 pi over 6. So same thing, you probably want to start by converting this to degrees. So we'll multiply by 180 over pi, cancel out the pi's. Multiply straight across, so 900 over, 900 over 6 there, which reduces to 150 degrees. So we're finding the reference angle for 150. So you start the positive x-axis. You go counterclockwise past 90, all the way over here somewhere to about 180, so that'd be a 150 degree angle. Then the reference angle, so we're going to take 180 minus 150, and that leaves me with a 30 degree reference angle. That's that acute angle from the terminal side. So now here's where it kind of becomes useful. We'll evaluate some trig functions here. So evaluate cosine of a negative 150. So by itself, that might not mean a whole lot. It does say give an exact answer to, by the way, which means we want it in simplest radical form and fraction form, no decimals. So cosine of negative 150, like I said, might not mean a whole lot, but let's take a look at the reference angle. Maybe that'll be a little more helpful than trying to figure out cosine of negative 150. So again, start the positive x-axis. Come out here to about negative 150. But I don't really care about that. What I care about is my reference angle here, which would be 30 degrees. Now, how is that helpful, you might ask? Well, we can make our nice little right triangle here. And I'll actually draw it out maybe a little better here. So here is my 30-degree angle, there's my right angle, and my 60-degree angle, so we have a special right triangle. How neat. All right, let's go. And what can we do with that? Well, we want to find cosine of our reference angle. So, like I said, we could start at cosine of negative 150, or we could use our reference angle, and then we might have to play around with the negative sign a little bit here. So we'll take a look at that. So I'm trying to find cosine of 30 degrees, actually, my reference angle. So here's 30 degrees, and hopefully you remember SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what I care about here is cosine. So cosine is cosine of 30, cosine of my angle is adjacent, so that would be this side. So the setup here, by the way, I should probably have written that. My setup is going to be 1, and then we would double it to get the hypotenuse, and then we would take it times the square root of 3 to get the long side. Excuse me. So the setup here would be the adjacent side, which is right here, the square root of 3, over the hypotenuse, 2. So the cosine of 30 is the square root of 3 over 2. And cosine is, so that would be over here, by the way, cosine of 30. But I want actually the cosine of negative 150, but I'm using my reference angle, so I can make a quick change here. So cosine of 30 degrees is equal to, so cosine is actually negative out here in the third quadrant. So all I need to do is do that, add a negative sign, and away we go. Another way you can kind of think of that is, so sine always deals with sine involves the y-axis or the y values. Cosine involves your x-axis or your x values. So you look back here, here's where your x-axis is negative, so cosine is negative. So that would be the exact answer we're looking for, not a decimal. Let's try another one. Evaluate sine of 120. So first you want to draw your angle. So 120 would be here somewhere between 90 and 180. But again, oh man, we want to use our reference angle. Go ahead and find that section again. We'd rather use our reference angle, so you take 180 minus 120 and you get 60 degrees. And again, we can make our nice right triangle. So that would make this side 30, and then our setup would be side opposite of 30 is 1. This would be 2, and then the square root of 3. So I want to find the sine of 60 degrees, my reference angle, and sine is opposite over hypotenuse. So from my reference angle here, I need to find the opposite side, which is the square root of 3 over the hypotenuse, which is 2. Okay, now we need to decide, is this a positive or a negative? So sine of 120 is, so again, I don't know if this is really going to help you, but if you remember, sine is your y value, or deals with your y values. Cosine deals with those x values. You look at the y-axis. If you were on the positive side of the y-axis, then that means your answer is positive. So we have sine of 120 is the same thing as sine of 60, or the square root of 3 over 2. Okay, evaluate. This is the last, well, we could do a couple more, but I mean, these are really no different. This is the last example I'll do here. Try to keep the video a little bit shorter for you. But evaluate cotangent of 4 pi over 3. So you get a radian like this. You want to first convert that to degrees. So 4 pi over 3 times 180 over pi. The pi's will cancel. Multiply straight across. You get 720 over 3, which reduces to 240. So that's the angle, that's the angle we're looking at using. So you start the positive x-axis, you go counterclockwise, 240, so it's somewhere here, because remember this is 180, this is 270, so somewhere between those two. Here we are. So now we need to find our reference angle. So this one's a little bit different because we started at the positive x-axis and we came all the way around. We passed 180. So what you're kind of thinking of here, so the whole thing is 240 degrees. Well, right here would be 180. So how much more than 180 would that be? You could subtract 240 minus 180 if you want to think of it like that. But either way you look at it, you get a 60-degree reference angle. So you notice how this keeps coming back to our 30, 60, 90, or 45, 45, 90 special right triangles. That's kind of why we want to use these reference angles for these exact measures. So here's my right triangle again. This would be the 30-degree side, and opposite of that, we always put 1. The hypotenuse is going to be 2, and then the square root of 3 is opposite of our 60-degree angle. Now, cotangent is the same thing as the opposite of tangent, basically. So let's start with that. So tangent is opposite over adjacent. So that means that cotangent would be adjacent over opposite. And remember, you always go from your reference angle there. So if I want to find cotangent of, we said 60 degrees, and then again we are going to have to decide if it's positive or negative. Excuse me. So we need the adjacent side, which is going to be 1, over the opposite side, which is going to be the square root of 3. Now, it would be great if we could leave it like that, but we cannot have radicals in our denominator. So what we need to do quickly is rationalize. So we multiply the top and the bottom by the square root of 3 over the square root of 3. Up top, I have just the square root of 3 because anything times 1 is just itself. On the bottom, I have the square root of 9, which is just 3, so no more radical. So to simplify, the cotangent of 60 degrees is the square root of 3 over 3. So now what we need to decide is what is the cotangent of 240 degrees, or 4 pi over 3 if you want to put the radian back in there. It does not matter. Same thing. So we need to decide, is cotangent positive, negative, or I guess those are the only options, positive or negative. So cotangent, now cotangent and tangent both deal with x and y together. So in the first quadrant, x and y are both positive, so tangent and cotangent are both positive. In the third quadrant down here, I'll do this. In the third quadrant down here, x and y are both negative, but two negatives make a positive, so cotangent and tangent would still stay positive. So cotangent of 240 over 3 would be the square root of 3 over 3, the positive version. So there are a couple more here, example 5 and example 6, where you're first going to have to convert these to degrees, and then you might involve the 45, 45, 90 triangles. But that is it for